Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will go through reflections. So this is the third and final part of our videos on transformations. We went through translations, which are when you just slide the shape. We went through rotations, when you turn a shape. And reflections are where you flip a shape. So you take a shape like this and you flip it over to get this one there. So remember, the new shape that you end up with is called the image. And just like for rotations and translations, when you reflect a shape, its image is the same size and shape, but we're just changing its orientation, the way it's facing. So when you flip or reflect a shape, you need a line here called the line of reflection or the mirror line. And we say this shape is reflected about this line here. All of these points on the mirror line are fixed. They don't move when we reflect a shape. So how do we actually then reflect a shape? What we're going to do is show you that by reflecting this triangle here. So similar to what we've done with rotations and translations, if I want to reflect the whole shape, I just reflect each of its vertices or corners. So this red line here is going to be our mirror line or line of reflection. So what you do to reflect a shape is you reflect each of its vertices one by one. So this is how you reflect the vertices. So if I want to reflect vertex A here, what I do is I draw a line from vertex A to the mirror line, and it needs to hit the mirror line at 90 degrees. Then what I do is I extend this line. I'm going to keep drawing it down here so that it's the same length. And then I simply move A to the other side. So, of course, A, we move it to A dash. That means the image of A. So what we've done to go from A to A dash, these 2 points A and A dash are the same distance from the mirror line, but A dash is just on the opposite side. So A dash goes there. Now, what about vertex B? Well, vertex B is on the mirror line. Remember I said all of the points on the mirror line are fixed. They don't move. So vertex B dash would actually be here as well. When we reflect this shape, vertex B would not move. B dash would still be here. So let's do something similar for C that we did for A. So what I do is I draw a line from the vertex to the mirror line at 90 degrees, and then I'm going to extend the line onto the opposite side of the mirror line. So what we have is that this distance here and this distance here are the same. So I'm going to move C here to C dash. So C and C dash are the same distance from the mirror line, but they're on opposite sides of the mirror line. So when I've got all my vertices, all I have to do now is join them up. And there we have it. This shape here is the image of that shape there. They are the same size and shape. This one is just a different orientation. You can see the vertices have been reflected as well as the shape. So that's how you perform a reflection. Of course, apologies, I can't use a ruler on the iPad, but you should always use a ruler when you're reflecting a shape. All right, let's now look at reflectional symmetry. So we looked at rotational symmetry when we did rotations. That's about rotating a shape and making it look identical to the original. But make sure you know the difference. This is a different type of symmetry. Reflectional symmetry is what people commonly call symmetry. If you hear lines of symmetry, they are talking about reflectional symmetry. So reflectional symmetry means you can draw a mirror line somewhere in the shape, down the middle of the shape, and cut it in half exactly. So let's look at these three triangles here. So how do they differ? This one has no pairs of equal sides. This one has one pair of equal sides. And in this one, all three sides are the same. And it turns out they will have a different number of lines of symmetry. So this first shape here has no symmetry. You cannot draw a line, a mirror line, anywhere in this shape that will cut it in half exactly. So that's why this has no lines of symmetry. But if the triangle has one pair of equal sides, remember the dashes mean the sides are equal, it will have one line of symmetry, and that will be down here. This is a line of symmetry that I've drawn roughly because it cuts the triangle in half exactly. This side of the triangle is a reflection of this side of the triangle and vice versa. So these two halves of the triangle are identical, just reflections of each other. So if the triangle has three equal sides, it turns out it has three lines of symmetry. I could cut it in half perfectly down here. I could also cut it in half perfectly down here, or cut it in half perfectly here. Notice that each of these lines of symmetry is a line that emanates, it starts from one of the vertices. So this one here has three lines of symmetry. That only works if the triangle has three equal sides. And each of these lines is a line of symmetry because what it does is it cuts the triangle in half perfectly. In other words, if you say cut it down here, this triangle, this side of the triangle, is a perfect reflection of this here. I've drawn a bit rough, but this, if I use this as the line of symmetry, this here is a reflection of the other side there. This is like a mirror line. So let's look at some quadrilaterals. So this one here is a rectangle. And contrary to what a lot of people think, a rectangle only has two lines of symmetry, one here and one here. This diagonal line here is not a line of symmetry, so I'm going to rub it out. So why isn't that diagonal line a line of symmetry? Well, let's say that you took a rectangular piece of paper, and you can try this. If you folded, so this corner here ended up on this corner here, you wouldn't fold it in half exactly. This corner would end up like over here. You can't actually fold a rectangle perfectly in half by putting this corner here. So if I folded it along this line here, it wouldn't fold the rectangle in half. That's why that's not a line of symmetry. A square, on the other hand, where all four sides are equal and there are four right angles, it actually does have four lines of symmetry. See, this is a line of symmetry for a square, because if you folded a square along this line here, this half would fit perfectly on top of this half. In other words, this triangle is a perfect reflection of this triangle. Similarly, this is a line of symmetry. Square also has the same lines of symmetry as a rectangle. So a square has four lines of symmetry, two diagonal, one up and down, one left and right, whereas a rectangle only has two lines of symmetry. So think of a line of symmetry as something that cuts the shape in half perfectly. Think of it as a mirror line. Each side of the mirror line is a reflection of the other side. Another way to think of a line of symmetry is a line that you could fold the shape in half. If I folded this shape along this line, it would fold it in half perfectly. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.